Hi everyone, here's the solution for Chapter 6, Homework number 5, Problem number 9. A student in G period asked for clarification on this one. So if we take a look at the picture, we have a three-dimensional picture, and they're asking us to complete the statement by using less than, equal to, or greater than. And so we have to compare the measure of angle 1 up here in this corner to the measure of angle 2 down in that corner. And the real key here is finding two triangles that you can compare. So what I'd like to do now is just add some letters so that we can name our triangles. So I'm going to go from A at the top, name this point B, point C, and then let's name this point D. And what you should notice is that we have triangle ABD, which I'm going to try to highlight here. So from A to B to D is one triangle. And then we also have triangle DBC. So that's this triangle. Good choice, green on green. All right, but hopefully you can see those two triangles. And the real key is that it's difficult to understand that this angle of 55 degrees obviously is bigger than this angle of 50 degrees in the other triangle, just because of the way in which it's drawn. It certainly appears that the 55-degree angle is smaller. That's just because of the perspective, because of it being a three-dimensional picture. Okay, so if you were to redraw those two triangles separate from the picture itself, come off to the side here, and we've got triangle ABD that looks something like this. Don't assume it's a right angle, my friends. Okay, so this is 55, and this side length has a length of 7. And then triangle CDB, and this side CB has a length of 7. This angle is 50 degrees. Well, don't forget what the two triangles share and have in common is a side. So what we have here are two sides of one triangle congruent to two sides of another triangle. But the included angle of this first triangle, 55, is greater than 50, the included angle of the second triangle. So based off of that, by the side angle side inequality theorem, we can say for sure that AD, the third side in the first triangle, is definitely greater than DC. Okay, so these two triangles, ADB and this triangle DCB, are being compared, so we can make a conclusion about these two side lengths. I'm going to highlight them in like this reddish color. So AD and CD can now be compared. Now, AD and CD are also sides in that third triangle, and if AD is the longer side, it's going to be opposite the larger angle. So therefore we can say for sure that the measure of angle 1 is less than the measure of angle 2. And that's because we can say for sure that CD is less than AD. So hopefully this helps you to understand this three-dimensional picture. Alright, so it looks like we have another three-dimensional problem here that we have a question on. So it's good that we did that one from homework number 5, so hopefully you listened to that description. We're trying to make a conclusion about the angles in triangle UVE. And all the information we have so far is that we've got one angle that measures 60 degrees. So I'm just going to pull that triangle out so we can see it. So here it is, 60 degrees, and it's on the left-hand side of the figure over here. So we're given that the measure of angle EVU is 60, and then we're also given this key statement. The line segment OE, kind of our base, if you will, of that front triangle, the big triangle that looks like this. This is the whole face, if you will, VEO. And so this is what we know about it. That line segment EO, or OE, is congruent to line segment OU. which is in a third triangle, kind of on the right-hand side of the figure. And that triangle is VUO. And of course, we know that this side, OU, is congruent to EO. Okay, next we're going to take a look at what these two triangles, VEO and VUO, have in common. Okay, so first of all, they have a pair of corresponding sides that are congruent, and we also know that they share a side in common. Of course, VO would be congruent to VO. So mark VO congruent to VO because they share that side in common. So it certainly looks like we're going in the direction of the side angle side inequality theorem again. So next we're going to take and use our third piece of given information. It says the measure of angle VOE, which is this angle right here, is larger than, so we put an L for large, you could put a B for big or something, but angle VOE is greater than the measure of angle VOU, this angle. So I'm going to put a little s for small. Okay, so remember, according to this side angle side inequality theorem, if two sides of one triangle are congruent as two sides of another triangle, but the included angle of the first triangle is greater than the included angle of the second triangle, then the third side of the first triangle, VE, has to be greater than the third side of the second triangle, VU. Okay, so keep this in mind. Go back to this triangle now. We know that this angle is 60 degrees, and now we know VE is greater than VU. If VE is greater than VU, then angle U, the measure of angle U, must be greater than the measure of angle E. Okay, so we know that angle U is greater than E. So again, I'm going to put the L for large, the S for small. And now the question is, well, how do they compare to 60 degrees? So think about this. If you have 180 degrees in a triangle, and you've used up 60 of them, you have 120 degrees left. Angle U and angle E can't be equal to each other, so they both can't be equal to 60. So the measure of angle U has to be greater than 60. And the measure of angle E has to be less than 60. So to finally answer the question, since the measure of angle U is greater than 60 and angle V is actually equal to 60 degrees, then the measure of angle U is the largest angle in the triangle. And I should say you should actually call it angle VUE, just to be more specific. I know in our little triangle it's easy to see where angle U is. In the big triangle we're referring to this angle right here.